We have these two incredible blueprints for the universe. Quantum mechanics for the tiny stuff, general relativity for the big stuff. But here's the staggering thing. Try to use them together, and they break completely. It's maybe the biggest intellectual clash in science today. So this deep dive, for anyone who's genuinely intellectually curious, we're not focusing on settled science, but on those few huge unsolved problems in physics that really push our theories to the limit.
That incompatibility you mentioned, that's absolutely central. It really drives so much research. The math of the Standard Model, our quantum rule book, and general relativity just fundamentally don't work together. They both give nonsense answers under extreme conditions, think the Big Bang, or deep inside a black hole. And that failure, that inconsistency, is the main engine behind the hunt for a theory of everything.
Okay, let's pause for just a second. This deep dive is sponsored by Embersilk.com. If you're looking into AI education or integration, they're the answer, helping cut through the noise and focus on what works. Embersilk.com. Right, so if that QM and GR conflict shows the limits of our knowledge, then what the universe is actually made of shows the sheer scale of what we don't know. We've got these powerful theories, but they only explain, what, about 5% of the cosmos?
Just about 5%, yeah.
So let's dive into that missing 95%, the cosmic dark sector.
That's definitely the place to start. Dark matter, well, its identity is still a complete mystery. Is it some kind of particle, maybe a WIMP, or perhaps an axion, something else entirely? And what deepens the puzzle is that, as of 2025, all these big direct detection experiments, they haven't found anything concrete. It makes you wonder, could the gravitational effects we see actually be pointing towards maybe a modification of gravity itself, an alternative theory?
And if dark matter is like the missing cosmic glue holding things together, then dark energy is what? The force pushing everything apart faster and faster.
Exactly. It's responsible for the accelerating expansion of the universe. And this is where things get profoundly weird. Dark energy connects to something called the cosmological constant problem. Basically, our quantum theories predict a certain energy for empty space, the vacuum energy, but the value we actually observe. It's different from the theoretical prediction by about 120 orders of magnitude.
120.
Yes, it is by far the worst prediction in the history of physics, just a staggering mismatch. And compounding this, there's the Hubble tension. Recent data, including from JWST up to 2025, suggests the universe is expanding faster right now than our standard models predict based on the early universe.
The measurements don't line up.
Right. It's getting harder to dismiss as just error. It might be hinting at, new physics or maybe even questioning our whole standard model of cosmology.
Okay, let's shift gears. From the scale of the universe down to sort of the fundamental rules, we ran into another huge conceptual problem. The black hole information paradox.
Ah, yes. This one hits right at the core conflict. So Stephen Hawking predicted black holes aren't totally black. They should slowly radiate energy away, Hawking radiation. It's still theoretical, mind you. We haven't observed it yet as of 2025. But if they evaporate, what happens to all the information about the things that fell into them?
Because quantum mechanics says information can't just be deleted.
Precisely. It's a fundamental rule. Information is conserved. So does the information vanish, meaning quantum mechanics is wrong in this extreme case? Or does something else happen? Maybe the black hole doesn't fully evaporate like GR suggests. One of our pillars has to give way. It's a massive theoretical confrontation.
And it's not just these exotic scenarios. There are cracks appearing even in areas we thought were pretty well understood, like the neutron lifetime puzzle.
That's a fascinating one because it's so concrete.
Yeah.
And persistent. You have two main ways to measure how long a free neutron survives before decaying. One method traps them in a sort of bottle. The other counts them as they fly in a beam. Both methods are incredibly precise now, but they give different answers. Consistently different.
How different?
The disagreement is significant, statistically speaking. Somewhere around 3 to 5 sigma. That means the chance it's just random error is incredibly small, like 1 in millions.
This is probably real.
It strongly suggests something's missing. Maybe a new particle interaction, something beyond our current standard model, is influencing the decay. It shows even established physics has these nagging questions.
And maybe the deepest, most sort of philosophical puzzle of all, why does time only flow one way, the arrow of time? Entropy, disorder, always increases. We remember the past, not the future. But the basic laws of physics, they seem to work just fine forwards or backwards in time. They're time symmetric. So why the direction?
It's a profound asymmetry built into the fabric of reality that emerges from time's symmetric laws. We still don't have a complete explanation for why that macroscopic arrow exists. If you tie all these threads together, dark matter, dark energy, information paradox, neutron puzzle, even the arrow of time, they all point in a similar direction. They highlight the need to somehow unify quantum mechanics, gravity, and understand the universe's full composition, well beyond our current standard model. That unified picture is still the ultimate goal.
Okay, so here's a final thought for you, the listener, to maybe mull over. The quest for a theory of everything isn't just about finding the ultimate rules. It also makes us ask, are things like the speed of light or Planck's constant, these fundamental numbers we measure, are they truly fundamental? Or could a final theory perhaps derive them from even deeper, maybe purely mathematical principles? Could they be explained rather than just measured? Thanks for joining us on this deep dive into some really challenging frontiers. If you found this journey into the unknown interesting, please do subscribe, and if you can, leave a 5-star review. It genuinely helps other curious minds find the show.